Hello and welcome to this Gardasoft presentation on 6 key considerations for machine vision. Lighting and lighting control are sometimes thought critical only in complex machine vision configurations. In truth, they can be just as vital in the simplest of applications. Lighting and lighting control are vital elements of machine vision because they have a massive influence on the quality of the captured image. Machine vision software can only deliver intelligence from information present in the captured image, so optimizing the lighting should be an essential consideration for every application. This presentation reviews 6 key considerations for obtaining effective machine vision lighting. We'll look at the quality of the image, and then we'll go on to getting the most out of your LEDs, how important it is for flexibility, looking at the relevance for illumination stability, making easy setups, and utilizing your network capability. Optimizing your image. The best possible camera image has optimum levels of contrast and signal-to-noise ratio. These two measures are determined by the amount and quality of the light falling on the camera sensor. Reduced light levels increase image noise and reduce contrast, making it more complicated to process the image and consequently more difficult for the purposes of accurate measurement or product classification. In addition to ensuring that the right amount of light reaches the camera sensor, it's also essential to ensure that light levels are consistent. Variable light intensity can result in poor measurement repeatability, with major repercussions in a manufacturing environment, leading to excessive waste, defective product reaching the end user, or even line stoppages. Attempting to use image processing software to enhance low-quality images is often both time-consuming and ineffective. Crucially, image processing can only manipulate data that is captured by the sensor. It cannot create information that is not present in the original image. Therefore, it is the quality of illumination that defines the intelligence available, and both lighting and the way lighting is controlled in a machine vision system should be carefully considered. Providing inadequate lighting control is likely to lead to significant underperformance from the machine vision system. This slide shows a simple example of how reducing light intensity on a fast-moving object correlates directly with reduced image quality. Longer camera exposures are required to compensate for reduced lighting intensity, which in turn leads to motion blur. Getting the most from your lighting. As described earlier, delivering the correct amount of light into the scene is critical to getting accurate, reliable results. LED lighting is generally specified as either 12 volt or 24 volt supply, but the brightness is determined by the amount of current running through the LEDs and not the voltage across them. This means that good current control is necessary to accurately adjust the light intensity. In addition, LEDs heat up during use, and this changes both their forward voltage and their efficiency, so that brightness will vary over time. LEDs are remarkably reliable devices, but their light output will deteriorate over time as a consequence of repeated heating and cooling cycles. Typically, an LED would be replaced when its output falls to below 70% of its initial rating. Driving an LED continuously will generate the most heat and create the lowest device lifetime. Switching the light on only when an image is being acquired by pulsing the light will minimize the amount of heat produced and significantly improve LED lifetime. Pulsing can be achieved most easily by using a lighting controller to manage the strobing. Converting a constant illumination system to a strobe system is straightforward when using a quality lighting controller. The trigger for the camera is sent to the lighting controller, which allows adjustment of pulse length and intensity, and any delay between trigger and output pulse. This ensures that the lighting pulse occurs consistently at the same point in the camera exposure, and that the total light energy is identical for every image. A lighting controller also allows the total light output to be managed to balance the intensity needed against the need to maximize LED lifetime. Strobing an LED light brings significant benefits because when the timing and duty cycle are carefully controlled by the controller, the light can be overdriven to achieve light intensities much higher than the manufacturer's light rating. This is an extremely useful technique in many scenarios. For example, if the inspection speed increases and a shorter camera exposure is needed, Overdrive can provide the additional intensity required, necessary to maintain image quality. Pulsing the light also allows the image capture of objects moving at high speed without image blur, as I mentioned earlier. Gardasoft controllers have fine adjustment of pulse timing, which is often more accurate than the camera's internal timing. While overdriving is a very powerful technique, it is necessary to ensure the LED is not driven at too high a current for too long, which may damage the light. Gardasoft has developed SafeSense technology to impose safe working limits on overdrive based on manufacturer specifications, pulse width, and duty cycle. SafeSense technology also ensures that the maximum current rating for the LED is not exceeded during continuous operation. The heat generated within the controller itself must also be controlled, and Gardasoft designed its Safe Power technology to minimize the heat dissipation in the controller by automatically adjusting the lighting supply voltage. This allows lighting to be driven with high continuous currents without heat sinking the controller. I'm going to take you through 3 slides now showing an example of a benefit from overdriving the LED lighting. Here we have an object requiring 2 surfaces to be in focus. Under nominal conditions, only the top surface is in focus. The natural thing to do would be to stop down the aperture to increase the depth of field. To increase the depth of field by stopping down makes the image too dark. By overdriving the LEDs by 400% brings the image back to a satisfactory condition for processing. Building in flexibility. A common occurrence in machine vision systems is for the requirements or the working environment to change. One of the most compelling benefits of including a lighting controller in your lighting system is the flexibility the controller brings in adapting to changing requirements and environment. If the system is configured to use continuous lighting, the inclusion of variable lighting control allows the intensity to be adjusted to suit the application, meaning that the same lighting can be used with different intensity settings for different product batches. For example, the inspection of reflective objects would require a lower brightness than would be needed for objects with more diffuse surface finishes. The ability to switch to pulsed mode can also lead to a reduction in average power consumption and an extension of lighting lifetime. Making use of overdrive mode for LED lighting offers even more flexibility without requiring hardware change. Operating in continuous mode, the controller can be set up for any inspections requiring light intensity up to the 100% of the LED rating. However, since LEDs can be safely overdriven at up to 10 times the maximum rating in short pulses, a much wider range of components can be inspected with existing hardware by utilizing Overdrive. For example, inspections may be required on batches of products of different sizes. Overdriving allows the depth of field to be increased by using higher f-stop lens settings, while maintaining image brightnesses by increasing light intensity above 100%. And I demonstrated this with a few slides earlier. Another common example is where an established system becomes adversely affected by ambient or other light sources. If the light is already running at its maximum rating in continuous mode, then pulsed mode Overdrive offers scope to increase brightness further and overcome the light interference. A combination of increased brightness and either reduced camera exposure or reduced aperture size can significantly reduce ambient light interference. Dedicated lighting controllers are frequently multi-channel devices which permits a multitude of illumination sequencing configurations for the system designer, allowing several different images to be produced from a single station. Each image may require a unique configuration of lights, geometry, illumination levels or cameras, but a lighting controller will enable them all to be achieved at a single inspection station, frequently reducing costs. Sequencing different lights from a single Gardasoft controller enables a turnkey solution for dark field, bright field optimization, red, green, blue sequencing, or other forms of computational imaging. Maintaining stable illumination. As explained in section 2, the brightness of LED lighting is proportional to the current running through the device, and for this reason, all LED device manufacturers recommend using current control. In fact, a very small change in LED drive voltage will result in a much larger change in light output intensity, as shown in this slide. For example, a 10% increase in voltage across an LED light will double the current, which will double the light output. This is a critical factor, since even for simple vision caliper measurements, a 10% change in light level can cause a change of 0.5% in the measured values, which would be unacceptable in many industries. In this image, for example, a very small change in light intensity makes quite a big difference in the grey level values on the image, and this would significantly affect any type of caliper measurement. How to make the setup easier. A well-designed lighting controller can bring significant benefits to the configuration and use of machine vision systems. Opto-isolated trigger inputs, if provided, can be used to connect to all common signal sources, and a digital button front panel allows easy and instant configuration of lighting. The controller should incur minimal delay between the trigger signal and the light pulse, and Gardasoft provides controllers such as the RT-CC range, which have inbuilt timing functionality for applications requiring more sophisticated timing, such as configurable delays and multiple triggers, and also setting up triggers for the reject systems. The system can be set for either an external signal to trigger both the camera and the lighting controller, or for a signal from the camera to trigger the light. Where UKIVA compatibility is provided, the controller becomes a discoverable device on the machine vision network. The web pages built into Gardasoft controllers provide live measured values of the current through and the voltage across the light, which is essential data for determining light performance. SafeSense continually monitors the use of the light, preventing unsafe levels of overdrive and protecting the light from damage. Gardasoft provides a useful vision utility, which includes an image viewing window displaying the actual image produced by the camera as a result of the selected timing settings. This makes it very easy to see the real-time effects of adjusting the parameters. Once the image has been optimized, the settings can be saved, and this can be repeated for as many channels as the controller offers. The Gardasoft Vision utility integrates with all of the most popular image processing software. Utilizing network connectivity. One of the most important recent breakthroughs for machine vision is the establishment of the UKIVA and GenyCam standards. This has brought enhanced connectivity, the ability to integrate vision systems and lighting controllers with other Ethernet components, and the reassurance of interchangeability between UKIVA compliant components from different manufacturers. A controller with Ethernet connectivity will enable remote access to all the lighting within a system and indicate whether a light is connected, disconnected, or short circuit, for example. Ethernet communications also offer the possibility of remote troubleshooting a vision system, which is invaluable when you could be many hundreds of miles away from your client. Adjustments might be made to increase the current into a light whose intensity has reduced due to aging. Ethernet connectivity also enhances flexibility by allowing the configuration of a lighting controller to be changed, for instance, to suit different batches of product. Using an application such as the Gardasoft Vision utility, it is possible for the machine vision control software to select a batch type and directly communicate with the controller to set the configuration required for that batch. The use of Trinity-enabled lights provides additional operational intelligence information, such as how long that light has been used for and how many triggers it has received. Let's sum up on all the things that we've learnt during this presentation. Lighting has an enormous influence on the quality of the captured image. By making sure that the lighting is accurate and consistent, we'll ensure that the machine vision software receives all the data that is potentially available and yield the best results. Thank you for listening to this presentation on the 6 key considerations for machine vision control. I hope you found it informative. If you'd like to discuss anything further, please get in touch, please send me an email or contact us through our website. And we hope to speak to you soon. Bye-bye.